Learning objectives. In this chapter, the users would learn the following aspects of PCAT motherboards: the motherboard, the various parts of the motherboard and its architecture, the elements of motherboard, keyboard interface circuit on the motherboard, P4 motherboards, CMOS setup and their features in detail, CMOS concept, extended and expanded memory, cache memory, shadow memory, different types of memory such as EDO RAM, SD-RAM, RD-RAM, DDR-RAM, etc. Specifications of a latest Pentium 3 and Pentium 4 based motherboard and chipsets, concept of BIOS, POST, its error codes and their interpretation. DOS, internal and external commands of config.sys file and their order as sample of config.sys and autoexec.bat files, IRQ, PNP. DOS, otherwise called as a disk operating system, is an operating system developed by IBM in the 1980s and prevalent till early 90s. These operating systems exploited machines with Intel x86 and other compatible processing units. The program could run on non-compatible hardware also because it was developed for non-IBM computers as well. This operating system is a single user with single task at a time operating system. Various programs could run on this operating system. DOS characteristics. This operating system is characterized by the interface in application programming, which offers an opportunity to develop applications which are character-based. Even when there is a possibility, the access was restricted to the hardware, printers, mouse, or graphics. This resulted in developing each application program with its own set of device drivers. Just like Windows, the DOS operating system also used an 8.3 system of files. The FAT file system used for storage supported nearly 4,078 clusters in each drive. The FAT file system supported hard drives with capacity more or equal to 137 GB. History of hard disk. When IBM introduced the IBM PC, they needed an operating system. In 1980, they approached Bill Gates of Microsoft to discuss the state of home computers and inquire as to what help Microsoft can provide to IBM. Gates provided IBM with some great ideas to make their home computers popular. IBM settled a deal with Microsoft in which Gates agreed to write a Windows version for IBM. After the development of Windows, Bill Gates talked to IBM to retain the rights of the MS-DOS. Early development of DOS. MS-DOS versions have attained several upgradations which are as follows. In 1981, MS-DOS 1.0 was released. In August 1982, MS-DOS 1.25 was released. In March 1983, MS-DOS was released. In April 1986, another version of MS-DOS 3.2 was released. MS-DOS 3.3 was released in April 1987. Subsequent versions of MS-DOS 4.0 and 4.01 were released in July and November 1988. MS-DOS 5.5 was released in June 1991. MS-DOS 6.0 was released in the month of August of 1993. In 1993, another version of MS-DOS 6.2 was released. In 1994, MS-DOS attained further development through 6.21 and 6.22 versions in the months of March and April. Design of DOS. Most MS-DOS systems run on machines with compatible CPUs. Machine-dependent versions of MS-DOS were produced for many non-IBM compatible machines. DOS appears as a single-user and single-task operating system. It works with basic kernel functions that are non-reentrant. DOS allows only one program to run. Even its functions didn't allow functioning of more than one program at a time. The DOS kernel provides various functions for programs. The functions are I/O, file management, memory management, program loading, and termination. DOS offers a primitive ability for shell scripting through batch files. These are the text files that can be created in any text editor. These batch files are executed as compiled programs are executed. The executed programs are able to run each line of batch files as command. Along with this, several batch files are utilized to make several internal commands. These commands are go to and conditional statements. Apart from these commands, the command named go sub and simple arithmetic can attain the supportive hand from dr-dos command. With aid of batch files, no real-time programming is attained so far. The disk operating system offers an application programming interface that allows character-based application development. These applications are not designed for accessing hardware such as graphics card, printer, or mice. Due to this limitation, the programmers can access the hardware directly. The hardware is accessed through a set of drivers made separately for each hardware device. DOS uses a file system that supports 8.3 file names, in which 8 characters are meant for file names and 3 characters are defined for extension. Command of DOS. Operating systems like MS-DOS and PC-DOS use a number of system commands. These include common tasks like listing or moving files. Some of these commands were given as external commands, but for some functions the command interpreter incorporated on the disk was used. With every new generation and model of the operating system, new commands were added to the existing ones. Even now, the text mode command can be used in MS-DOS. The use of command interpreter is possible when there are no programs running. The inbuilt command .com will always try to match the lines typed by the user with the available commands and execute the program. Internal and external command of DOS. The internal command or the inbuilt command is a list of commands available with the operating system. These commands are there to choose from to execute the programs. As and when new programs are introduced, the next versions of the computer will be made with a command to execute the new program. According to certain parameters set, one command could accept certain file names. Spaces and symbols were used to shift between different files and functions. Commands to perform complex applications were stored as external commands, as they were too large to be processed in a command processor. They were stored on disks and as and when needed, loaded onto the computer, like any regular application. These utility commands were available in an accessible disk or in a command path installed in the command interpreter. Password setup. Many times you need to acquire the BIOS password for a particular machine. This may be to break the CD drive, or possibly you had forgotten the password. By using a CMOS password program, you can extract the password for most BIOS. Actually, CMOS password is an open source program that is used to read binaries for Windows and DOS. To execute the program, you need an administrative privilege. Since DOS is a command line interface, you can use command prompt. Along with the creation of password, DOS also helps in changing the password. Usually, changing of password is done to keep away the intruders from accessing your system. With the aid of DOS command prompt, you can easily change the password of your Windows as and when you desire. Password setup steps. You need to follow certain simple steps. Close all the programs. Click on the Start button on the bottom side of your desktop. Click on the Run command and type command in the blank space. Click on Run or Open. Type NetUser username. You can put the username in the name of your administrator name, which you often use to log into your computer system. Press Enter key on your keyboard. When prompted for the password in the given field, type the password and confirm it by typing again. DOS batch files. The batch file represents a script text file containing the commands for the command interpreter to execute. The commands present on the batch file will be accepted by the command interpreter using an interactive prompt. Within a batch file itself, sometimes the commands for looping and branching can occur. Batch files are usually added to the control language to ensure that the regular task can be automated by setting up a script for it. In DOS, the file extension to designate batch file is BAT. The starting of a batch file in MS-DOS can be attained by typing the name in the command line along with the other required parameters and pressing the Enter key. Usually the setup commands of MS-DOS, which needs to be run when the MS-DOS starts, will be kept in autoexec.bat. This autoexec file, with date and time loads necessary resident programs, initializes networks, starts the drivers, and assignments. Configuration of batch files. DOS batch files are run by Microsoft's Internet Information System, IIS-3. But when the files are made to run under IIS4, then several things need to be configured. Once the configuration steps are followed, the batch files can be made to run on the server side. The steps are: run the IIS4 Management Console application. Follow the editing process of your website. For this, you can right-click on your website in the tree display and select Properties section. Follow the process by selecting the Home Directory lab. In the Application Settings box, click on the Configuration option and select it. On the App Mapping tab, click Add. The executable must be the following on a WinNT 4.0 machine. This goes with typing the command c:\winnt system32 command.exe c%s%s. In case of extension, enter .bat. While following the steps, make sure the script engine and check that files exist checkboxes are selected. Save the process by clicking OK. Apply OK and OK. Unix operating system. Unix is written in assembly language. B was replaced by C, and Unix, rewritten in C, developed into a large complex family of interrelated operating systems, which is influential in operating systems. Unix runs on a wide variety of computer architecture. It is used in servers of all business as well as in workstations in academic and engineering environments. The POSIX standard can be applied to any operating system, although it was originally created for various Unix variants. Linux operating system. Linux is a Unix-like operating system that was developed with Unix code. The kernel of Linux is released under the open source license and is used in popular distributions such as Red Hat, Debian, Ubuntu, Linux Mint, and Google's Android. It is used on a wide range of devices from supercomputers to wristwatches. Creating and editing of DOS batch files. Batch files are text files, so all is needed is the creation of Windows Notepad application. While creating this application, it is advised not to use WordPad or word processor like Microsoft Word. These files fail to produce pure text files as they add their own formatting. To create a simple batch file, you need to run a single command that is typed into a text file and saved with a .bat extension. When you double-click the file, it will run your command. When it comes to editing DOS batch files, the MS-DOS editor is used. It is a command that allows you to view, create, or edit any file on the computer. When you run the edit command, a screen on the computer appears. The edit command is an external command that is available in a variety of Microsoft operating systems. They are Windows 95, Windows 98, Windows ME, Windows 2000, Windows Vista, Windows 7, and many more. In some Windows like Windows Vista and Windows 7, edit command is available in the form of Notepad. Notepad can be started from the Windows command by using the Start button. With the aid of edit command, you can also create files. For example, if you want to create a file called myfile.txt, you may type the command edit myfile.txt. By typing this command, you will get a blank edit screen. Once you exit, the file is saved as myfile.txt. Commands of configuration system file. The main command used in MS-DOS is config.sys to load the programs of the computer to memory, followed by setting up the memory management system. The instructions in the command shell are executed after the processing of config.sys. The next job to be executed is loaded by the file autoexe.bat. Some of the configuration system commands are: buffers denotes the quantity of memory present between memory and the disks for the transfer of data. Country defines what kind of conventions are to be used. Device, it prompts the loading of a device manager, which manages the physical components like mouse and memory card. Device high, loading of device manager is targeted to the upper memory. Back defines whether the system should use the high memory and give a provision to access upper memory area. DRIV PARM specifies the features of disk drive. Files, the number of simultaneously open files in MS-DOS. Install indicates a loading of a program. Numlock determines whether the keypad locking is on or off. Set in order to adjust the variables like temp. There are other commands like shell, stacks, switches, and many more with specific functions. IRQ. In computers, there are occasions where a special program has to be run in order to rectify some defects which occurred while working. IRQ, or interrupt request, does the job of sending a hardware signal to the processor to stop temporarily the running program to allow the special program to run by an interrupt handler. The priority of the request is determined by the interrupt request level. In the commands, the interrupt lines can be identified very often by an index of IRQ, which normally appears after a number. In the command, this will appear as IRQ0 through IRQ7. In more advanced x86 family of computers, it will appear like IRQ0 through IRQ15. The integration of an advanced programmable interrupt controller, APIC, in the newer x86 systems support the programming interface for a large number of physical hardware. PNP. PNP, or plug and play, indicates a string of specifications in Microsoft Windows in the operating system and device configuration. The native inbuilt devices in the Windows will support the configuration, connectivity, and management to the complete function of the operating system. It otherwise refers to the interface and responsibilities coming along with the driver development. The main feature of a PNP function is that in most of the cases, it allows the detection of devices completely independent of the user. Sometimes a minor occasional configuration is needed in the device memory maps. PNP is not a hardware specification. PNP requires the device to be configured in such a way that it can be easily managed by the system hardware by providing the resource allocations available in the operating system. PNP functions will be started at the booting time itself. The compatible components will be identified and non-conflicting addresses will be given. Pentium 4. Pentium 4 comes in the line of single-core central processing units marketed by Intel. It had microarchitecture. It is referred to as NetBurst, which is composed of 7th generation x86. NetBurst is characterized by very high processing speeds, generally absent in P6 processors, by involving an instruction pipeline which is very profound. While the initial reports claimed a clock speed of nearly 10 GHz for the NetBurst, the heat dissipation issues severely restricted the performance to very low level. Only 3.8 GHz of processor speed is recorded, especially with the version Prescott. The desktop processor, introduced in 2000, further improved in the later periods and now has 9 different models at present in the market. The initial expansion was done in 2004, when the 32-bit x86 instructions was extended by 64-bit x86-64 set. The first generation of Pentium 4, or Willamette, had a processing speed of 1.3 to 2 GHz. In the third generation, named Prescott, the new SSE3 instruction improved the processing of transactions, graphics, calculations, games, and other transactions. The later versions of Pentium 4 were characterized by the technology of hyperthreading. The hyperpipeline technology helped the CPU to execute instructions in doubles or triples compared to previous version of Pentium 3. Further, this technology helped the single PU to function as 2 separate logical processing units. Features of Pentium 4. The Pentium 4 processor can handle large data sets and manage its transfer and handling. This indicates an improvement in performance compared to the previous generation. Pentium 4 is useful in applications like financial analysis, where large amounts of data is analyzed simultaneously. The horizontal applications like MS Word may have a setback even though the processor speed is significantly increased. However, the recent trend is that the Office applications use extensively the data-intensive graphics, which will be supported heavily by Pentium 4. The increased use of technologies like XML and Java in the web applications, Office, and Windows XP enhance the application levels of Pentium 4. The 2-integer ALU improved the core frequency of the processor twice, meaning half the clock cycle is required to execute the instructions. This feature enhanced further the applications like video decompression and online secure interaction with the encryption technology to ensure the transfer of data and other transactions related to e-commerce. So the increased and improved architecture of Pentium 4 will support larger data handling, and it can be imagined that even if there is a difference in the cost, the additional features of Pentium 4 give it a strong chance. As there is no possibility to increase the processor speed of Pentium 3, the more advanced applications coming out in future will be supported only by the Pentium 4 processor. The processor is supported with an integrated system for heat spreading, which protects the unit from damage. Specification of Pentium 4. With regard to the specifications of Pentium 4, the speeds of the processor belonging to the different versions ranged between 1.3 to 3.8 GHz. While the first version, Willamette, had a die size of 217 square millimeters in comparison to 131 square millimeters of second version Northwood and 112 square millimeters of Prescott. The transistor count between the three versions are 42 million in Willamette, 55 million in Northwood, and 125 million in Prescott. The micron process difference between these three versions are 0.18 Willamette, 0.13 Northwood, and 0.09 Prescott. The front-side processor bus has a capacity to run at 400 MHz, 533 MHz, 800 MHz, or 1066 MHz. A hyperpipeline technology is used in Pentium 4 CPUs. The hyperthreading technology is available with processors faster than 2.4 GHz. There is an improved branch prediction in Pentium 4. There are 13 deep instructions which are new for the processing of sound and graphics. The units for enhanced floating point is very high. The different low power status improves the performance considerably. With 8-way associativity, the L2 cache has a core speed of 256 bit wide. A 4 GB RAM can easily be handled by an L2 cache and can support ECC. In extreme editions, the L3 cache has an on-die value of 2 MB instead of the previous version's 1 MB. The initial versions of Pentium 4 used the socket 423, in which 423 pins were arranged in 39 by 39 SPGA form. In the later versions of socket 423 is replaced with socket 478 or socket T provided with additional pins, and they supported many of the new and advanced features like EM64T and the virtualization technology. Pentium 4 based motherboard. There are different memory packages used in the motherboards using Pentium 4 as a processor. These include RD-RAM, DDR-SD-RAM, SD-RAM, or DDR2 SD-RAM. In general, most of these motherboards used either DDR2 SD-RAM or DDR. In comparison to earlier processors, the power consumption of Pentium 4 is much higher. Therefore, in the motherboards, a new design of voltage regulator is attached with a 12-volt supply instead of the previous 3.3 or 5 volts. With the higher voltage source, the overall power consumption is greatly reduced. The motherboard utilizes only 12 volts and the remaining power is available for the rest of the system performance. In order to utilize the excess power supply, an adapter is connected to the power connector. So a typical 300-watt power supply is needed. The cooling system in Pentium 4 needs an active heat sink. This may lead to vibration or shock, eventually leading to the damage of the motherboard. To prevent this, the socket 423 is used, which support to keep the heatsink retention structures. Socket 478 and socket T LGA775 further enhance the protection of the motherboard. Pentium 4 chipset. The Pentium 4 chipset has the following properties. 400 MHz system bus. It means, in comparison to the previous versions of the Pentium, the fourth version has a data processing rate of 3.2 GB per second. Advanced transfer cache. It controls the initial 5 steps of hyperpipeline. The L2 cache is 256 KB, does the data prefetching and reads 64 bytes in single go. Hyperpipeline technology helps the faster propagation of signals in the circuits. The technology allows nearly 72 instructions at a time. On misprediction, it may take longer time to refill. enhanced floating point, and the multimedia. Enhanced and highly advanced instruction set. The chipset showed enhanced applications in computing and internet. Execution trace cache. It is the L1 cache behind the decoders. It integrates the codes. The IA32 instructions decoded will be stored by this part. Rapid execution engine. NetBurst microarchitecture uses this component as the execution core. Parallel execution is facilitated by rapid execution engine. Advanced dynamic execution. It makes sure that the execution units function properly. It has an enhanced algorithm. Microarchitecture. The NetBurst architecture was unclear, so the Pentium 4s were created with optimization of application code. But Pentium runs more slowly than its predecessor. Since Pentium 4 posed new optimized code, it rejected its emphasis on clock frequency and became a marketer's dream. This resulted in the NetBurst microarchitecture. Pentium 4 family. Intel Pentium 4 is a family of high-performance microprocessors that succeeded Pentium 3 family. Pentium 4 CPUs are based on new NetBurst microarchitecture used in Pentium 2, Pentium 3 microprocessor. The NetBurst microarchitecture used different approach. It attempted to improve performance primarily by increasing CPU frequency, often at the expense of efficiency. Successor. The ultimate successors to Pentium 4 are the Intel Core 2 processors using the Conroe core based upon the Core microarchitecture released on July 27, 2006. Intel Core 2 processors have been released as single, dual, and quad-core processors. Single-core counterparts are present in the Intel Core 2 lines, primarily for the OEM market, along with dual and quad-core processor. Processor core. Pentium 4 processors have an integrated heat spreader, IHU, that prevent the die from accidentally being damaged when mounting and unmounting cooling solutions. A CPU shim was sometimes used by people worried about damaging the core. The integrated heat spreader is directly soldered to the die, which makes it difficult to remove. Overclocking to 2.8 GHz P4. It uses the retail cooler. We began to up the FSB slowly. We hit the wall at 147 MHz FSB, which only gives us 3.09 GHz while using 1.6 V. The limitation may be due to the hardware, which is the PSU. Introduction to CMOS. CMOS stands for Complementary Metal Oxide Semiconductor. It is a technology that is used for integrated circuits. This technology is incorporated in microprocessors, microcontrollers, static RAM, and other digital logic circuits. It is an onboard semiconductor chip that is powered by a CMOS battery inside computers. It is used to store information like system time, date, and hardware settings for the computer. In other words, it is used to store BIOS, BIOS, basic input-output settings. The lifetime of CMOS batteries of a motherboard can be up to 10 years. However, this can vary in certain cases and can need replacement. It is also known as non-volatile BIOS memory. CMOS is the most common method of making processors and memories. In CMOS technology, both negative and positive transistors are used. They are used in a complementary way to form a gate that forms an effective means of electrical control. CMOS transistor uses almost nil power when not needed. However, when there is a rapid change in the current direction, the transistors become hot. When only one of the circuit types is operating at any given time, CMOS chips require less power than chips using just one type of transistor. The CMOS technology is also used for image sensors based on analog circuit, data converters, and highly integrated transceivers that are used for different types of communication. CMOS circuits were invented by Frank Wanlas in 1963 at Fairchild Semiconductors. The first CMOS integrated circuits were made in 1968. CMOS is basically a low-power but slow alternative to TTL. CMOS is being implemented in fields where battery life was more important than speed. The CMOS circuits, manufactured in early periods, could easily get damaged. Later generation of CMOS circuits were well designed to overcome this issue. CMOS technology has steadily improved eventually becoming the technology of choice for digital circuits. Aside from low power consumption, CMOS circuits are also easy and cheap to fabricate, allowing denser circuit integration than their bipolar counterparts. Characteristics of CMOS. The two important characteristics of CMOS are its high noise immunity and low static power consumption. As one of the transistors is always off, the series draws significant power only when switching between on and off states. As a result of this, the CMOS devices do not produce much waste heat. There are a few other important characteristics of CMOS such as duality, logic, dissipation. Duality. The duality that exists between PMOS transistors and NMOS transistors is an important characteristic of CMOS. A CMOS circuit is designed in such a way that there is a path always that allows output to either the power source or the ground. This is achieved by defining one in terms not of the other. The PMOS transistors in parallel have the NMOS transistors in series, and the PMOS transistors in series have the corresponding NMOS transistors in parallel. This is based on De Morgan's law. The set of all pathways to the voltage supply must be the complement of the set of all paths to ground. Logic. Complex logic functions require the manipulation of paths between the gates to represent the logic. But in the case of CMOS, the logic is simple. When the path has two transistors in series, the transistors should be modeling an AND. That is, both transistors must have low resistance to the corresponding supply voltage. When the path has two transistors in parallel, either one or both transistors should have low resistance to connect supply voltage to the output, modeling an OR. Dissipation. In addition to all this, CMOS dissipates low power. The power dissipation is dependent on the power supply voltage, frequency, output load, and input rise time. The propagation delays are short and are based on the power supply. It has controlled rise and fall times. The levels of logic signal are equal to the power supply as the impedance is also high. The fundamental concepts of CMOS. To understand the fundamental concept of a CMOS, it is necessary to understand what exactly a CMOS does. It does a function of storing information that the computer needs when it boots up. If the battery that powers the CMOS RAM dies, then all the information is lost. In this situation, the PC will boot with CMOS basic defaults. It is always better, and in fact it is recommended, to keep a copy of all the information stored in CMOS. CMOS uses a combination of P-type and N-type of metal oxide semiconductor field effect transistors, MOSFETs. Using this, it implements logic gates and digital circuits that are found in computers, telecommunications, and signal processing equipment. The typical commercial CMOS circuits are integrated circuits made of millions of transistors of both types. These are commonly referred to as chips. In CMOS logic gates, a collection of N-type MOSFETs is arranged as a pull-down network between the lower voltage power supply rail, VSS, and the output. It has a collection of P-type MOSFETs in a pull-up network between the higher voltage rail, VDD, and output instead of the load resistor of NMOS logic gates. The output node is present where the pull-up and pull-down network intersects. This exhibits some internal capacitance which is charged or discharged through pathways formed by P by NMOS networks for various inputs. The internal capacitance is charged while there is a direct path from voltage rail VDD to output. It is discharged while there is a direct path from output to voltage power supply rail VSS. It is to be noted that the CMOS circuit cannot be pulled up or pulled down simultaneously. The two types of transistors are complementary, which means when one is on, the other is off. CMOS logic dissipates less power than NMOS logic. This is because CMOS dissipates power only when switching. It is referred to as dynamic power, whereas NMOS logic dissipates power whenever the output is low. This is referred to as static power. Introduction to motherboard. When we open a desktop computer case, we see many boards with circuit transformers and wires soldered to them. There is one large board that all other boards connect to. It is the motherboard. The motherboard is a piece of computer hardware that can be compared to the backbone of a PC. It does the job of connecting all parts of a computer together, eventually making them into one unit. It is a main circuit board in a computer that creates a way for the hardware in the computer to communicate with each other. The motherboard is also called as main board, MOBO, logic board, and system board. Motherboards are present both in laptops and desktops. In laptops, they are packed tightly. The motherboard not only connects the components of a computer, but also provides power to the systems that need low power. The motherboard contains a socket in which one or more processors are attached. In addition, it has slots that allow connecting peripheral cards such as video cards, sound cards, and networking cards. It has a chipset that provides interface between the various subsystems of a computer. The ROM is held with the help of BIOS. This is the memory that does not get erased when the computer is turned off. This happens with the help of the set of instructions that help the computer recollect what has to be done when it is switched on. The motherboard also has a clock generator. This helps the computer synchronize various operations. In addition to all this, the motherboard also has slots for expansion cards and power connectors. The first, second, and third generation computers were built in a mainframe. The components were connected by a backplane that consisted of a set of slots that were interconnected with wires. It was replaced with circuit boards that became the standard practice in the 1970s. The various components were housed on a printed circuit board that was plugged into the backplane. In 1980s and 1990s, it was found that the increased number of peripheral functions on the PCB was becoming economical. Therefore, single integrated circuits were being included on the motherboards. In late 1990s, motherboards started to have full range of video, audio, storage, and networking functions on them. History, compatibility. The early pioneers in the field of motherboard manufacturing were Elite Group, Oki Technology, DTK, AMI, Micronics, Milex, etc. But soon companies like Apple and IBM took over. Companies like Apple and IBM were able to offer high-end, sophisticated motherboards that included features and superior performance over the older motherboards. Nowadays, motherboards have a wide variety of built-in features. They have become an important component without which the computer does not function, and they also directly affect its capability, performance, and potential for upgrades. Today, Intel and Asus are the two leading companies in the manufacturing of motherboards. The different types of CPUs, memory, video cards, disk drives, and other peripherals are supported by different types of motherboards. If a motherboard is being replaced, it is necessary to ensure the components are compatible with the slots and connector types on the motherboards. The disk drives have different standards and connectors. Some of these components can be upgraded as newer technologies evolve, but only to a point. It is better to purchase a new motherboard if you're considering a major upgrade for improved and faster performance. Often a motherboard can support IDE, SATA, or even both. Expansion card slots also do vary. It is necessary to ensure the motherboards opted for works with the hardware best. Performance and differences. Computer builders agree upon the fact that a motherboard has minimal effect on performance when all other factors are the same. But still, upgrading a motherboard can support more memory, faster CPU or video cards. In simple words, it increases the performance similar to the effect of replacement of other elements. Each motherboard is different. They can be different in design, size, shape, capabilities, and configuration possibilities. Some may look the same and yet have subtle differences. These differences are dependent upon the form factor and manufacturer. In the early days of the industry, when computers were introduced in the market, there were very few differences and actually only a few motherboards were available. As the industry stepped forward, the computer began to take on popularity for many different reasons and a variety of motherboards were launched. Memory. There is an internal storage area in the computer. The term memory recognizes data storage that comes in the form of chips, and the word storage is used for memory that exists on tapes or disks. Moreover, the term memory is usually used as a shorthand for physical memory, which means the actual chips which are capable of holding data. Some computers also use virtual memory, which means expanding physical memory onto hard disk. Every computer is manufactured with a certain amount of physical memory usually, which is termed as main memory or RAM. You can think of main memory as a collection of boxes, each of which can hold a single byte of information. A computer that has 1 megabyte of memory, therefore, can hold about 1 million bytes or characters of information. Categories of memory. There are different categories of memory which are extended memory, expanded memory, shadow memory, cache memory. Extended memory and expanded memory. Extended memory means any amount of memory that is available for use over and above the main memory that is inbuilt in most systems. It means that any memory over the 1 megabyte that is supported by DOS would be considered extended memory. Extended memory is considered when the memory is greater than 1 MB and it is called upper memory or high memory area. Memory of this type is maintained by the use of certain types of processors that allow stacking and access to the extended memory. Extended memory is only available in PCs with an Intel 80286 or later processor. In addition, with the extended form of memory, many systems are also able to support what is known as expanded memory. Until the release of Microsoft Windows 3.0 in 1990, expanded memory was a chosen way to add memory to a PC. The alternative method, which was called extended memory, was less flexible and could be used only by special programs such as RAM disks. The difference between extended and expanded is that the expanded memory is configured to meet a specific published standard that is known as EMS. This standard works with DOS to allow access to the extra memory and makes it possible to use that memory for certain tasks. Shadow memory. Shadow memory is a copy of Basic Input-Outputs Operating System (BIOS). It is essentially a duplication of the routines inherent in the Basic Input-Output Operating System or BIOS of a computer system. Access in shadow memory is typically in the 60 to 100 nanosecond range, whereas ROM access is in the 125 to 250 ns range. Depending on the type of operating system used, the shadow memory may be used at startup or boot and at certain times during the operation of the device. In Windows and OS/2, however, these routines are not used and the use of shadow RAM is not necessary. In some systems, the user can turn the use of shadow memory off or on. Cache memory. A CPU cache is a cache used by the central processing unit of a computer to cut the average time to access memory. Cache memory is random access memory, RAM, which is smaller and that which the computer processor can access more quickly and faster than the regular random accessory. As a processor processes data, it looks first in the cache memory, and if it finds the data there, which was captured from a previous reading of data, it does not have to do the more time-consuming reading of data from larger memory. Cache memory is sometimes explained in levels of closeness and accessibility to the processor. Pentium processor. The Pentium is a widely used personal computer processor from the Intel Corporation. A 32-bit processor introduced by Intel in 1993. It replaced Intel's 486 microprocessor as a microchip of choice in manufacturing a personal computer. It contains 3.3 million transistors, nearly triple the number contained in its predecessor, the 80486 chip. Though still in production, the Pentium processor has been outdated by the Pentium Pro and other newer Pentium processors. Since 1993, Intel has developed the Pentium 3 and more recently the Pentium 4 processors. Pentium 3 processor. The Pentium 3 processor comes with a synchronized dynamic random access memory (SDRAM), allowing for an extremely fast transfer of data between the processor and the memory. The Pentium 3 is a processor designed by Intel as a successor to its Pentium 2. The Pentium 3 is faster, especially for applications written to take advantage of its cut-my new instructions. The 70 new computer instructions make it possible to run 3D, imaging, streaming video, speech recognition, and audio applications more quickly. All CPUs with cut-my core were released during a short period of time. In addition, the Pentium 3 offers clock speeds up to 800 MHz. There are different variants of Pentium 3, namely cut-my, Coppermine T, and Tualatin. Katmai. Katmai was a code name for Intel's first Pentium 3 core processor. Katmai was the first variant in Intel's 32-bit Pentium 3 family of processors and supplanted Pentium 2 processors. It was released in February 1999 with a speed of 500 MHz. In September 1999, Intel released the latest and the fastest Katmai 600 MHz CPU with 133 MHz FSB. Katmai's key innovation was a new instruction set called Katmai New Instructions, which was later renamed to Streaming Single Instruction Multiple Data SIMD extension SSE. The Katmai-based Pentium 3 CPUs had 512 KB backside L2 cache running at half of the core frequency. Coppermine. Intel released first processors with Coppermine new Pentium 3 core base on 0.18 micron technology. Better manufacturing technology resulted in smaller die size of the CPU, due to which it became economically feasible to incorporate 256 KB level 2 cache on the die. Although the size of integrated L2 cache was 2 times smaller than the size of L2 cache in previous generations of Pentium 2 and Pentium 3 processors, the advantage of the cache was in its speed as the cache was running at processor frequency. Coppermine processors were produced in speeds ranging from 500 MHz to 1000 MHz. Intel declared and shipped limited quantities of 1133 MHz processors. Coppermine T. Coppermine T is a revision of an intermediate chip between Coppermine and Tualatin, with support for lower voltage system logic present on the latter, but core power within previously defined voltage specs of the former, so it could work in older system boards. It is based on P6 micro architecture. Tualatin. Tualatin core boasts almost the same architecture as Coppermine. Even the enlarged L2 cache didn't cause any structural changes. Tualatin features the same on-die advanced transfer cache, working at the core frequency with a 256-bit access bus. The cache memory is split into 8 areas, and one cache line is 32 bytes long. Intel removed the CPU serial number support from Tualatin, which used to be a typical feature of older Pentium 3 processors, and raised a controversial reaction among the users. Tualatin is a different exterior of the CPU itself. The hoax is that the processor spends less time getting the data if the prediction is correct. Architectural features of Pentium 3 processor. Pentium 3 processor has architectural features such as P6 dynamic execution microarchitecture, dual independent bus, a multi-transactional system bus, and Intel MMX enhancement technology. In addition to these, it has 2 very useful features, such as the processor serial number and streaming SIMD extensions SSE. P6 dynamic execution microarchitecture. The P6 core was a 6th generation Intel processor in the x86 line. The technique of tentative execution and out-of-order completion is called dynamic execution by Intel. It forecasts program implementation through multiple branches, accelerating the flow of work to the processor. It generates an optimized, restructured schedule of instructions by analyzing data dependencies between instructions. It carries out instruction execution theoretically. Based on the optimized schedule, it ensures that processor's superscalar execution unit remains occupied. It boosts overall performance of the processor. Dual Independent Bus. The Dual Independent Bus DIB architecture was first implemented in the 6th generation processors from Intel and AMD. DIB was created to improve processor bus bandwidth and performance. Pentium 3 processor supports a high-performance Dual Independent Bus. DIB places the L2 cache on a committed high-speed cache bus, allowing for the system bus to be free from cache traffic. The processor reads and writes data to and from the level 2 cache using a specialized high-speed bus, which is called the backside bus. It's separate from the CPU to main memory system bus, which is now called as a frontside bus. It offers up to 3 times the bandwidth performance over a single bus architecture processor. It also supports the evolution to a 100 MHz system bus. A multi-transactional system bus. The system bus operates at 133 MHz, which allows 33% increase in existing bandwidth to the processor, which means 100 MHz system plus 33 MHz system additionally. The bus supports multiple outstanding transactions to increase the availability of bandwidth. In addition, it also provides glueless support for up to 2 processors, SECCE2 package only. It facilitates low-cost, two-way symmetric multiprocessing, providing considerable performance boost for multitasking operating system and multi-threaded applications. Level 2 Advanced Transfer Cache. The Advanced Transfer Cache ATC comprises microarchitectural improvements to offer a higher data bandwidth interface between the Level 2 cache and Level 1 cache. Also, the processor core is completely scalable with the processor core frequency. The features of the ATC include non-blocking, full-speed on-dial Level 2 cache, 8-way set associativity, 256-bit data bus to the Level 2 cache, reduced latency interface to cache data as compared to separate caches. Performance is also improved over cache-on motherboard implementations throughout a dedicated 64-bit cache bus. Streaming SIMD extensions. The significant feature of the Pentium 3 processor is the Streaming SIMD extensions SSE. Streaming SIMD extensions is an instruction set extension to the x86 architecture designed by Intel and introduced in 1999. Usually the processors are SISD, which comprises single instruction and single data, thus processing one data in one instruction. MMX and SSE both contribute to the concept of SIMD, but they differ in the type of data they handle and the way they are supported in their processor. MMX instructions are SIMD for integers and SSE instructions are SIMD for single precision floating point number. MMS instructions operate on 2-bit integers simultaneously, while SSE instructions operate on 4 32-bit floats simultaneously. A major difference between MMX and SSE is that no new registers were defined for MMX, while 8 new registers have been defined for SSE. The SSE can be used in 3D graphics applications. Processor serial number. The processor serial number, or chip ID, is a unique identifier burned into the Pentium 3 processor that can be accessed over the internet, allowing e-commerce sites and others to know which machine is visiting a site or using a service. This has dragged Intel Incorporated to a major controversy, but Intel claims that processor serial number can add value to a wide range of applications in both business and consumer computing. The processor serial number can provide benefits such as security, manageability, and information management. Benefits of processor serial number. Security. The e-commerce depends on the assurance that only authorized people access confidential information. Applications that take advantage of the processor serial number can use that as another element of identification, thus increasing confidentiality. Similarly, processor serial number can strengthen the data security for the consumer websites who want to maintain a section, say, open only to their family members. Manageability. IT departments use different ways to track assets such as MAC addresses or BIOS's GUID, but Intel claims that all these could be erased, so are less reliable. But processor serial numbers can be reliably used, as once it is burned on the chip at the time of manufacture, it can never be erased. So designing applications using chip ID can help IT consumers to manage their resources more economically. Types of SSE instructions. The most advantageous feature of SSE is 128-bit architecture width. The basic approach was to double cycle the existing 64-bit data path. The performance benefit of selecting this format was to realize a 1.5 2x speedup while only having a 10% increase in die size. SSE is a rich set of 70 instructions which could be very useful for a Pentium 3 processor in 3 categories: SIMD floating point, new media instruction, and streaming memory instruction. There are different types of SSE instructions, namely SIMD FP instructions, data movement, conversion type, memory streaming. SIMD FP instructions. The SIMD FP instructions operate in parallel on all packed mode or the least significant pairs, which is scalar mode of packed data. The instructions use an architecturally observable new state. Adding the new state reduced the level of complexity and eased programming model issues. It introduced a new register file containing 8 128-bit registers, each capable of holding a vector of 4 IEEE single precision FP data elements. The SIMD instructions perform arithmetic on the respective elements in 2 registers, return a 4-element result vector to one of the 2 registers. Thus, the architecture allows 4 single precision floating point operations to be carried out with a single instruction. Conversion operations. The SSE supports several conversion operations including SIMD, FP to MMX technology for packed data, scalar FP to IA32 integers for scalar data. To optimize the commonly used 3D geometry computations of division, square, square root, the SSE introduced 2 instructions which are RCP and R square root. These instructions use hardware lookup tables and provide 12-bit precision. They are very much quicker and faster than their full IEEE counterparts, which are 24-bit. When greater precision is needed, using these instructions with a single Newton-Raphson iteration accomplishes almost the same level of accuracy at a lower latency and throughput. Memory streaming. One downside of SIMD engines is that they can easily increase the processing rate to a level above the memory system's ability to supply data. When this happens, the execution units stall or become poorly utilized, thus limiting the SIMD speedup. Intel increased the throughput of the memory system and P6 bus with a set of features called memory streaming. It includes prefetch, stream store, and enhanced write combining. Prefetch can bring data into the cache before the program actually needs it, thus allowing the software to overlap processing with long latency memory reads. Stream store instructions avoids throwing useful data out of cache and polluting it with useless entries. To improve the performance of streaming store, Pentium 3 enhances the write combining feature that has been built in all P6 bus-based processors. Performance. The Pentium 3 processor offers top performance for today and tomorrow's applications as well as quality, reliability, and compatibility from the world's leading microprocessor company. Users can look forward for excellent PC software performance and full compatibility with Intel architecture-based software. Processing power is extensive to allow for higher performance of business media, communications, and internet capabilities. Websites designed with Pentium 3 processor in mind will set free the full multimedia capabilities of the processor, which guides to an enhanced, exciting internet experience. Features used for testing and performance monitoring. There are different features used for testing and performance which will help the processor to identify the strength and weakness. Accordingly, if there is any improvement in terms of technology and performance, it can be taken into consideration. The features for testing and performance are built-in self-test, IEEE 1149.1 standard test access port and boundary scan, internal performance, incorporates on-die. Built-in self-test BIST offers a single stuck-at-fault coverage of the microcode and large logic arrays as well as testing of the instruction cache, data cache, translation look-aside buffers TLBs, and ROMs. IEEE 1149.1 standard test access port and boundary scan mechanism facilitates testing of the Pentium 3 processor and system connections throughout a standard interface. Internal performance counters for performance monitoring and event counting. Incorporates an on-die diode that can be used to monitor the die temperature. A thermal sensor located on the motherboard can monitor the die temperature of the Pentium 3 processor for thermal management purposes. Types of memory. Read-only memory. Read-only memory is a type of built-in memory that is capable of holding data. It contains the data read from the chip but not written to. Whether there is power or not, the content doesn't get affected in ROM. Once data has been written onto a ROM chip, it cannot be removed and can only be read. ROMs are used extensively in calculators and peripheral devices such as laser printers, whose fonts are often stored in ROMs. Most personal computers hold a small amount of ROM that stores vital programs such as a program that boots up or starts up the computer. It is non-volatile. Random access memory. It is the same as main memory. The term RAM refers to random access memory. It means you can both write data into RAM and read data from RAM. Unlike ROM, it is volatile, which means it requires constant flow of electricity. If the power is off, the data is lost. It is the most common and most easily accessible memory found in computers or laptops and devices such as printers. If a lot of programs are open in the computer at a time, the computer will swap the data in the memory between the RAM and hard disk drive. Over the evolution of computers, there have been different types of RAM used in computers. Types of ROM. You have already learnt about the basics of ROM, but you might now be interested to know its types. So there are different types of ROM. All of them have their unique characteristics, but it is good to know that they have two common things. These two common things are being non-volatile and being unchangeable for the stored data. So let us now learn the different types of ROM. These are PROM, EPROM, EEPROM, flash memory. PROM. PROM stands for Programmable Read-Only Memory. It is inexpensive and can be coded by anyone using a tool called a programmer. The chip comes blank and can be programmed only once by the user. It is more delicate than ROM. It is very good for prototyping the data for a ROM. To write data onto a PROM chip, you need a special tool called a PROM programmer or PROM burner. The process of programming a PROM is sometimes called burning the PROM. The difference between a PROM and a ROM is that a PROM is manufactured as blank memory, whereas ROM is programmed during the manufacturing process. EPROM. EPROM is erasable programmable read-only memory. These chips can be erased and rewritten a number of times. EPROM is a special type of memory that keeps hold of its contents until it is exposed to ultraviolet light. The ultraviolet light clears its contents, making it possible to reprogram the memory. It is configured using the EPROM programmer that supplies voltage at particular levels depending on the type of EPROM used. An EPROM eraser is not choosy. It will erase the entire EPROM. The EPROM must be removed from the device it is in and placed under the UV light of the EPROM eraser for several minutes. If it is kept for long, then it becomes over-erased. EEPROM. Electrically erasable programmable read-only memory. It is user-modifiable read-only memory that can be erased and written on frequently through the application of higher than normal electrical power. Like other types of PROM, EEPROMs maintains its contents even when the power is turned off. Also, like other types of ROM, EEPROM is not as fast as RAM. These chips can be written inside the computer using an electrical field rather than ultraviolet light. Flash memory. Flash memory, a type of EEPROM that uses in-circuit wiring to erase by applying an electrical field to the whole chip or to pre-arrange sections of the chip called blocks. Flash memory works much faster than traditional EEPROMs because it writes data in chunks, usually 512 bytes in size, instead of 1 byte at a time. Types of RAM. You have extracted the information on the types of ROM, but you might now be interested to know what is next. The next is types of RAM. So there are different types of RAM which can be used at different level of processor. It improvises the operation of the processor within the computers. So let us now learn its different types. These are SRAM, static RAM, DRAM, dynamic RAM. Static RAM. Static RAM uses an entirely diverse technology. SRAM retains piled-up information only in static form as long as the power supply is on. Static RAMs are expensive and consume much power. Static random access memory uses multiple transistors, typically 4 to 6, for each memory cell but doesn't have a capacitor in each cell. SRAM memories are used in particular for the processor's cache memory. To accumulate one memory bit, it needs 6 metal oxide semiconductor field effect transistors, MOSFETs. MOSFET is a popular SRAM type. MOSFET is one of the two types of SRAM chips. The other is a bipolar junction transistor. The bipolar junction transistor is very fast, but it consumes a lot of energy. Dynamic RAM. Dynamic Random Access Memory, DRAM, is a type of random access memory used in computing devices such as a PC. DRAMs are inexpensive. They are used effectively for the computer's main memory. It loses the stored information in a very short span of time, even when power is on. It has to be dynamic. This refresh operation happens automatically thousands of times per second. But the problem is, by refreshing every time, it consumes time and slows down the memory. DRAM has one capacitor and one transistor per bit as compared to static random access memory (SRAM), which requires 6 transistors. The capacitors and transistors that are used are exceptionally small. There are different types of DRAM: asynchronous DRAM, FPM RAM, EDO RAM, SDRAM, RDRAM, and DDR-RAM. Asynchronous DRAM. Asynchronous DRAM is a basic type of DRAM. Asynchronous DRAMs have links for power, address inputs, and bidirectional data lines. Even though this type of DRAM is asynchronous, the system is operated by a memory controller, which is clocked, and this limits the speed of the system. Nevertheless, the operation of DRAM itself is not synchronous. There are various types of asynchronous DRAM, which is RAS only, refresh ROR, and CAS before RAS, refresh CBR. ROR is a classic asynchronous DRAM type, and it is refreshed by opening each row in turn. The counter required for the refresh was incorporated into the main chip to reduce the level of external circuitry. This became the standard format for refresh of an asynchronous DRAM. FPM RAM. FPM RAM, or fast page mode DRAM, was the original form of DRAM. As such, it was the main type of DRAM used in PCs. Memory size was limited to the amount of slots that were available on the motherboard and the capacity of the processor to handle the RAM. Very expensive, very small sizes, which was between 8 MB to 16 MB. It is now well out of date, as it was only able to support memory bus speeds up to about 66 MHz. Clock timings for FPM DRAM are typically 6-3-3-3, which conveys 3 clock cycles for access setup and 3 clock cycles for the first and each of 3 successive accesses based on the initial setup. EDO DRAM. EDO DRAM stands for Extended Data Out Dynamic Random Access Memory. EDO was the immediate development after FPRAM. EDO DRAM was invented by Micron Technology, who licensed many manufacturers to build this RAM. It is a memory chip that improves the time to read from memory on faster processors such as the Intel Pentium. It comprises specifically manufactured chips that allow a timing overlap between consecutive accesses. Like FPDRAM, it is also able to operate at speeds up to 66 MHz. It has the added feature that a new access cycle could be started even though the data output from the previous cycle was still present. SDRAM. SDRAM stands for synchronous DRAM. It is a type of DRAM that is much faster than previous forms of RAM and DRAM. It was introduced in 1997. SDRAM is not an extension of older EDO DRAM, but a new type of DRAM entirely. It allows the synchronized reading of data with the motherboard bus. It eliminates waiting times as there is synchronization with motherboard. It waits for the clock signal before it reacts to control inputs. Clock timings of 5-1-1-1 with an addition of 3 cycles in comparison to EDO DRAM. Unlike FPM and EDO DRAM, this has frequency of operating from 66 MHz up to 150 MHz or even higher. RDRAM. RDRAM stands for Rambus Dynamic Random Access Memory. It is a fundamental departure from the previous DRAM architecture. This was designed by Rambus Incorporated. In 1997, Intel got the license of Rambus technology to use. RDRAM memory chips work in parallel to achieve a data rate of 800 MHz or 1600 Mbps. Since they operate at such high speeds, they generate much more heat than other types of chips. It is a memory subsystem that promises to transfer up to 1.6 billion bytes per second. The subsystem consists of the random access memory, the RAM controller, and the bus connecting RAM to the processor and devices. Since 1999, Intel has been using RDRAM in its Pentium 3 Xeon processors, and more recently in its Pentium 4 processors. DDR-RAM. DDR-SD-RAM or DDR-RAM, known as Double Data Rate Synchronous Dynamic Random Access Memory. It is a type of very fast computer memory. It's based on the same architecture as SD-RAM, but uses the clock signal differently to transfer twice the data in the same amount of time. It is a type of SD-RAM that supports data transfers on both edges of each clock cycle, which means the rising and falling edges, effectively doubling the memory chip's data. DDR-SD-RAM also consumes less power, which makes it suitable for notebook computers. DDR-RAM is designed for processors of 1 GHz and faster. Parts of a motherboard. Though at first the components of a motherboard appear complicated, it is easy to understand its parts and functions. The parts are broadly classified as sockets, slots, chipsets, non-volatile memory chips, clock generator, power connectors, slots for expansion cards. Back panel connectors and ports. These are connectors and ports that connect to external devices such as audio ports, USB ports, Ethernet ports, and display ports. PCI slots. PCI stands for Peripheral Component Interconnect. These slots are for connecting older cards like network cards, sound cards, and connector cards. These have, however, been replaced by PCI E-slots. PCI E-slots. This slot is for the latest expansion cards such as sound cards, network cards, graphics cards, and connector cards. CPU socket. The CPU is inserted in the socket. ATX 12-volt power connector. This connects to the 4-pin power cable or power supply unit that provides power to the CPU. North bridge. It is often referred to as Memory Controller Hub or simply MCH. This is a chipset that allows the interaction of CPU with RAM and graphics card. The motherboards of the latest CPUs do not have this component as it is being integrated in the CPU itself. Front panel USB connectors. This connects to the power switch, reset switch, power LED, hard drive LED, and the front audio ports. IDE connector. For the purpose of data transfer, it connects to the hard disks and optical drives. Lately, this is being replaced by SATA connectors. CMOS battery. It provides power to store BIOS settings. It also helps in keeping the real-time clock running. mSATA connector. It connects to the mSATA solid-state drive. Often referred to as Input-Output Control Hub, it is a chipset that enables a CPU to communicate with the onboard audio, Ethernet ports, USB ports, PCA slots, PCIe slots, and SATA connectors. SATA connectors. It connects to the optical drives, solid-state drives, and modern hard disk drives for data transfer. Fan headers. It provides power to the CPU heatsink fan and also to the computer case fans. RAM slots. The RAM is inserted in the slot. ATX power connector. It connects to the power supply unit's 24-pin ATX power cable that supplies power to the motherboard. Front panel USB 3.0 connector. It connects to the USB 3.0 ports at the front or top of the computer. Power and reset button. This is the onboard button to turn on, turn off, and restart a computer. Elements of motherboard. Motherboard form factors. The form factor of a motherboard determines the specifications of its shape, size, layout, and placement. The form factor influences where the individual components go and the shape of the computer case. There are several form factors that determine if PC can fit into the standard classes. Differences between form factors include physical size, shape, mounting hole location, feature placement, power supply connectors, etc. Almost all desktop motherboards fall into one of the following form factors, which are AT form factor, Baby AT, ATX, Mini ATX, Micro ATX, Flex ATX, LPX and Mini LPX, NLX. AT form factor. It is the oldest and biggest form factor. It remained popular until another form factor called Baby AT was introduced. AT had a width of 12 inches. It was difficult to install, service, and upgrade the board. Baby AT. The Baby AT was standard in the PC industry between 1993 and 1997. The design issues of Baby AT limited the amount and selection of peripheral cards that can be installed. The input-output ports were separate and mounted on the case and were connected to pin outs on the motherboard. This resulted in a jumble of ribbon cables. It is still being used today in Pentium class products. ATX. The ATX that was developed as an evolution of Baby 80 has 4 areas enhanced. These are easy usage, provided better support for present and future I/O, provided better support for current and future process technology. It reduced the total system's cost. In the ATX, the processor is relocated away from the expansion slots. This allows them to hold full-length add-in cards. The long side of the board was useful in hosting more onboard I/O. The power supply provided airflow through the chassis and across the processor, whereas in most Baby 80 platforms, the air was blown out of the chassis. There are different form factors of ATX. Mini ATX. The features are the same as ATX, except that it allows smaller board size. Mini ATX motherboards were designed with MODT, mobile on desktop technology, which adapt mobile CPUs for lower power requirements and less heat generation, which may be beneficial for home theater PCs, HTPC, in-car PCs, or industrial use. There is no single widely accepted form factor by this name. Micro ATX. This was an evolution of ATX that was developed to address new market trends and PC technologies. It supports current processor technologies, transition to newer processor technologies, AGP high-performance graphic solutions, smaller motherboard size, smaller power supply form factor. Flex ATX. It is a subset of Micro ATX design. It provides the opportunity for system developers to create personalized computer designs. It was designed to allow custom case and board designs to be manufactured. The system designs emerging from this factor are ability to support current socketed processor technologies, smaller motherboard size, ATX 2.03 I/O panel, NLX. It is a new low-profile motherboard that is designed to adopt new market trends and PC technologies. It has many improvisations. These are supports current and future processor technologies, supports new accelerated graphics port and high-performance graphics solutions, supports tall memory technology. NLX is a public specification that is widely used in many types of systems. LPX and Mini LPX. It is used mostly by OEM manufacturers. The LPX form factor is usually found on desktop PCs. Its case is a slimline, low-profile case. It has a riser card arrangement for expansion cards, that is, the expansion boards are parallel to the motherboard and not perpendicular. This allows smaller cases but limits the number of expansion slots. The LPX motherboard often has integrated video adapters and sound. Despite the high-quality product at low cost, the repairing and upgradation is difficult. It is not friendly for a home PC builder and also offers poor expandability, upgradability, cooling, and difficulty in use. CMOS battery errors and solutions. Once a CMOS battery has failed or become defective, it will not hold charge any longer. In such a case, shutting down the power to full power off state and starting it again will require manual intervention. In most cases, the user is presented with a message like CMOS checked some error. Press F1 to continue or delete to enter setup. This message will vary based on the manufacturer. Repeated displays of such messages during system startup are symptoms that the CMOS battery has died. In certain cases, if the system is powered after an extended period and such a message appears, it is an indication of the system battery dying and it needs replacement. It is also to be noted that such an error message can appear because of a power surge or a damaged motherboard. But if it is because the CMOS battery is dead, then how is it replaced? The CMOS battery is located in the computer motherboard and resembles a coin. Most of the CMOS batteries are held tight with a simple clip mechanism. The clip can be moved to remove the battery. Once this is done, a new battery can be slipped into the slot and the clip has to be snapped back to secure the battery. CMOS batteries are not very expensive compared to the other components of the computer. Their lifetime can be between 2 to 10 years based on many conditions like environment, temperature inside the computer, and how often the system remains powered off for extended periods. In other cases, like if there are problems with the date and time, or if it has expired, the battery needs to be checked. If one has forgotten the password, the CMOS battery has to be removed and the CMOS jumpers on the motherboard have to be cleared. If it is the CMOS configuration mismatch error, then the CMOS settings have to be erased and reconfigured. Advantages and disadvantages of CMOS. The advantages of CMOS are the reasons we are using it till date and are not replacing it by any other technology. CMOS processes have become well established and are becoming more mature day by day. The digital memory and processors have brought in continuous improvement and downscaling of CMOS processes. The circuit and system design in CMOS is supported by various resources. They are readily available at low prices. Disadvantages. There are also disadvantages to the CMOS technology. The leading-edge processors are not characterized or tuned for analog design. The mismatches in CMOS devices are very high. This hinders the reliability of analog processing in vision chips. Difference between CMOS and BIOS. We assume that CMOS and BIOS are the same, but actually they are not. They are different elements of the computer which make the computer work properly. CMOS is a semiconductor chip of SRAM. BIOS is executable code stored in ROM. CMOS is a type of integrated circuit. BIOS is a type of software that manages the computer hardware. CMOS is power-driven by a CMOS battery and contains your system settings and is modified and changed by CMOS setup only. BIOS on the motherboard contains the instructions on how the computer boots and is modified or updated with BIOS updates only. CMOS settings have to be saved in RAM memory. BIOS instructions are exploded to the chip. CMOS has the instructions which users are allowed to change. BIOS has the basic and standard instructions. CMOS chip is continually powered and when the system is off. BIOS doesn't have to be continually powered as code is stored in non-volatile memory. If content is lost in CMOS, it can be rebooted, but with BIOS it cannot be rebooted. CMOS is no longer employed at present. BIOS is widely used in many modern computers. P4 motherboard. It is a modern form factor that is a lot faster and has more processor cache than old chips. P4 supports many additional features such as PAE, SSE and SSE2. P4 is the Intel processor that was released in November 2000. It has a clock speed exceeding 2 GHz, which is greater than that of P3, that is a clock speed of 1 GHz. It has a 20-stage pipeline that boosts performance by increasing processor frequency. It also has a rapid execution engine that doubles the core frequency and reduces latency. This is achieved by enabling each instruction to be executed in half a clock cycle. It has a 400 MHz system bus that enables transfer at the rate of 3.2 GB per second. The execution trace cache optimizes cache memory efficiency and reduces latency by storing decoded sequences of micro operations. The improved floating point multimedia unit and advanced dynamic execution result in faster processing of demanding applications. The P4 CPUs are available for different socket types. Each socket has a number of pins which is clearly labeled on the motherboard. The main memory of the computer is inserted in RAM slots. The P4 motherboards support RDRAM, SDRAM and DDR-SDRAM. The drives of the computer are connected to the drive connectors. These additional devices are also connected to the computer's power supply. Performance factors. The bus architecture and type of components incorporated in the motherboard determine a computer's performance. A motherboard comes predefined with what can connect to it, clocking ability, amount and type of memory it can use, including ROM and RAM, the type of power supply it can use, the CPU type and speed, voltage limits, and the type of case that it can fit in. When a computer or motherboard is purchased without any special frills or extras, it is described as bare bones. If you're trying to build a computer for a specific purpose and are planning on adding your special preference of components and devices so that it'll work with your needs in mind, then you should start out with a bare bones system and add to it. Holistic facts on motherboard. The motherboard is the most important part of a computer. Though it is useless in isolation, we cannot think of a computer without a motherboard. Motherboards have brought about a great revolution in the way computers are designed. It is the most important factor that helped designing compact computers. The technological improvement in motherboards has grown in leaps that accommodate faster, lighter, and high-end capabilities. With the passage of time, we are able to see more innovations break through the market. Conclusion. In this chapter, the users are covered the following aspects of PCAT motherboards: the motherboard, the various parts of the motherboard and its architecture, the elements of motherboard, keyboard interface circuit on the motherboard, P4 motherboards, CMOS setup and their features in detail, CMOS concept, extended and expanded memory, cache memory, shadow memory, different types of memory such as EDO RAM, SD-RAM, RD-RAM, DDR-RAM, etc. Specifications of a latest Pentium 3 and Pentium 4 based motherboard and chipsets, concept of BIOS, BIOS, POST, its error codes and their interpretation. DOS, internal and external commands of config.sys file and their order as sample of config.sys and autoexec.bat files, IRQ, PNP.